What if one of the most important weapons in human history began as a failed attempt to cheat death? More than 1,000 years ago, in China, a group of Taoist alchemists were searching for something that had nothing to do with war. They wanted immortality. Their experiments involved minerals, chemicals, heat, and mysterious recipes that had been passed down through generations of alchemical tradition. The goal was simple: find the perfect substance that could extend human life forever. Instead, they created something that would eventually transform warfare across the entire planet: an explosive mixture. The ingredients were simple enough: saltpeter, charcoal, and sulfur. The result was anything but simple. When the mixture was heated, it burned with extraordinary speed, producing expanding gases and a violent burst of energy. The alchemists had been searching for eternal life. They had accidentally discovered the foundation of the modern firearm. That discovery would eventually lead to rockets, cannons, muskets, rifles, and weapons capable of changing the fate of entire nations. But none of that happened overnight. The journey from an alchemist's laboratory to the modern gun took centuries. It was a story of accidents, experimentation, military necessity, and ideas traveling across enormous distances. And the first step wasn't a gun at all. It was fire. Early gunpowder was initially used for purposes that seem almost harmless compared with what came later. It powered fireworks, it created spectacular explosions during celebrations, it produced smoke and noise for signals and ceremonies. For generations, people could encounter gunpowder as entertainment rather than as a battlefield technology. But eventually, military thinkers began asking a dangerous question: what if this explosive power could be directed at an enemy? The first answers were surprisingly primitive. During the Song dynasty, Chinese engineers developed a weapon known as the fire lance. The basic concept was straightforward: take a spear, attach a tube to it, fill that tube with gunpowder, then ignite it at close range. The result was a weapon that could suddenly release flame, smoke, sparks, and burning material toward an enemy. Imagine standing in a medieval battlefield preparing to fight someone with a sword or spear. Then suddenly, the weapon in front of you erupts in fire. The physical damage was only part of the problem. The psychological effect could be just as powerful. An enemy who had never seen anything like this might hesitate, panic, or break formation. And once humans discover that a new technology can work on a battlefield, the next step is usually to make it better. The fire lance began evolving. Instead of using gunpowder only to create flame, engineers started adding objects that could be thrown forward by the explosion. Small pieces of metal, ceramic fragments, other projectiles. Now, the weapon wasn't merely producing fire, it was launching objects with force. And that was the critical conceptual leap. The explosion itself wasn't the weapon. The explosion could be used to launch something else. That idea sits at the heart of virtually every firearm that came afterward. But there was a problem. The early tubes were often made from materials like bamboo. Bamboo was useful, it was available, it was relatively easy to work with, but it wasn't strong enough to safely contain increasingly powerful explosions. Push the pressure too far, and the weapon could split apart. Sometimes the person holding it was the one who paid the price. So the solution was obvious: use something stronger: metal. Once craftsmen learned to create durable metal barrels capable of containing the pressure of burning gunpowder, a new type of weapon emerged: the hand cannon. Now, a solid projectile could be placed inside a metal tube and propelled forward by rapidly expanding gas. The basic firearm had arrived. It was still crude, it was heavy, it was difficult to aim, it was slow to reload, but compared to a spear or bow, it represented something fundamentally new. A person could use an explosion to launch a projectile over distance, and the technology continued to expand. The same principles were applied to larger weapons: cannons, explosive bombs, siege weapons. Some were designed to destroy fortifications, others were intended to create chaos among enemy troops. And then something happened that would change the history of the technology forever: the Mongol conquests. As Mongol armies moved across Asia, they encountered the gunpowder weapons developed in China, and instead of ignoring them, they absorbed the technology. The Mongol Empire connected enormous parts of Eurasia. Military techniques, engineers, weapons, and knowledge could travel across distances that would have been difficult to cross through ordinary trade alone. Gunpowder technology moved with them. From China, knowledge traveled westward, into Central Asia, toward the Islamic world, eventually into Europe.
This was not a single moment when someone handed the world the gun. It was a long chain of transfers. Each culture encountered the technology, adapted it, and changed it. And gunpowder technology didn't follow just one path.
One branch led toward firearms. Another led toward rockets. Gunpowder-powered arrows and early rockets appeared in Asia and eventually influenced later developments far beyond their original use. The remarkable part is that both the firearm and the rocket can trace their ancestry back to the same basic discovery: a chemical mixture that burns rapidly enough to create powerful, expanding gases. The same principle could send a projectile through the air, or push an object forward continuously. Two very different technologies, one ancient chemical foundation. As gunpowder reached the Islamic world and Europe, it entered societies where warfare was already undergoing major changes. European armies began experimenting with their own versions of gunpowder weapons. The earliest firearms were not exactly elegant. Imagine holding a small cannon. Now imagine trying to aim it. You load the powder, insert the projectile, prepare the ignition, then try to keep the weapon steady while touching a flame to the firing point. There were no modern triggers, no precision sights, no reliable safety systems, and certainly no guarantee that your shot would go where you want it. But even an inaccurate firearm could be terrifying because armor could only protect you for so long. A heavily armored knight represented an enormous investment. Years of training, expensive equipment, a powerful horse, a social system built around the idea that elite warriors could dominate the battlefield. Gunpowder began challenging that system. A relatively inexpensive firearm could allow a less heavily trained soldier to threaten someone who had spent years preparing for traditional combat. The balance of power was shifting, and the battlefield wasn't the only place that changed. Architecture changed too. For centuries, castles had been designed around tall stone walls. Those walls were excellent against ladders, arrows, and many traditional siege weapons. But cannon fire created a new problem. A powerful projectile could strike the wall again and again until the stone eventually gave way. So military engineers redesigned fortifications. Walls became lower. They became thicker. Angles became more important. Fortifications began using shapes designed to absorb or deflect incoming fire. The classic medieval castle gradually gave way to the star fort. It was a completely different philosophy of defense, and all of it was connected to the growing power of gunpowder. But the next great challenge was smaller. How do you make a gun easier to fire? Early hand cannons required significant coordination. One hand held the weapon, the other had to bring a burning material to the ignition point. Try doing that while aiming at a moving target. It's difficult. The matchlock mechanism offered a clever solution. A slow-burning cord could be attached directly to the weapon. When the shooter activated the mechanism, the burning match moved to the priming powder. The gun fired. That small mechanical improvement changed everything. For the first time, the shooter could focus more attention on holding and aiming the weapon. The firearm was becoming less like a primitive miniature cannon and more like a true individual weapon. Matchlock firearms spread rapidly. Different societies adopted them. European armies used them. The Ottoman military incorporated them. Portuguese traders carried firearms into Asia. And in Japan, local craftsmen adopted and refined the technology into the famous Tanegashima matchlock. The technology had traveled thousands of miles from its original birthplace, and every society that adopted it had the opportunity to change it. But the matchlock had one major weakness. It needed fire. A soldier had to carry a burning cord. That created obvious problems. Rain could make the system unreliable. The glowing match could reveal a soldier's position at night, and keeping a burning cord ready even when no fighting was happening was inconvenient. So engineers looked for another solution: the wheel lock. Instead of relying on a continuously burning match, the mechanism generated sparks mechanically. This made the firearm more practical for mounted soldiers who needed to move quickly. But the wheel lock was expensive and complicated. It was difficult to manufacture, and armies still needed weapons that ordinary soldiers could afford. The next major breakthrough would solve many of those problems: the flintlock. The basic idea was beautifully simple. A piece of flint was held in a spring-loaded mechanism. When the trigger was pulled, the flint struck a steel surface. The impact created sparks. Those sparks ignited the priming powder. The gun fired. No constantly burning cord, no open flame sitting on the weapon. The mechanism was faster, more practical, more reliable, and far easier to use in the conditions of real warfare. By the 17th century, flintlock firearms were becoming the standard weapon of European infantry, and eventually they would become deeply connected to the history of the United States. The flintlock musket was the weapon carried by soldiers during the American Revolutionary era. British regulars carried them. American forces carried them. For generations, the sound of a battlefield was defined by lines of infantry firing volleys from these weapons. But there was still another problem. A musket was powerful at range. Up close, the soldier carrying it could be vulnerable. The solution was the bayonet. Early versions could interfere with the firearm itself, but the socket bayonet solved that problem. It attached around the outside of the barrel. The soldier could fire the gun normally. Then, when the enemy approached, the same weapon became a spear. This eliminated the need for large numbers of dedicated pikemen whose primary job was to protect musketeers. Now, one soldier could perform both roles.
Shoot at a distance, fight at close range. The entire structure of infantry warfare changed. Armies became simpler to organize, training became more standardized, and battlefield formations became increasingly disciplined. A soldier with a musket and bayonet was no longer just a shooter, he was a complete infantryman. The psychological effect of these formations was enormous. Imagine standing across an open field from hundreds of soldiers advancing toward you. Their weapons are loaded, their bayonets are fixed, their movements are coordinated. Sometimes the enemy broke before the lines even made contact. But even the flintlock had a weakness. Its ignition system depended on sparks and exposed components, and eventually engineers found a better solution: the percussion cap. This small metal cap contained a chemical compound that ignited when struck. The complicated sequence of flint, steel, and loose priming powder was no longer necessary. The mechanism became faster, more reliable, more resistant to difficult conditions, and with that, the major era of traditional muzzle-loading firearms was beginning to close. But the story didn't end there. Once engineers understood how to create reliable ignition, the pace of firearms development accelerated. Manufacturing improved, metallurgy improved, barrels became stronger, mechanisms became more precise, weapons became faster to reload. Eventually came repeating firearms, then rifles with increasingly sophisticated designs, and eventually weapons that would have seemed completely impossible to the soldiers who once carried matchlocks across European battlefields. Looking back, the history of the firearm isn't really the story of one invention. It's the story of a chain. One discovery creates a new possibility. That possibility creates a new problem. The problem inspires another invention, and that invention creates another opportunity. Bamboo couldn't handle enough pressure, so engineers turned to metal. Hand cannons were difficult to fire, so mechanisms were created. The matchlock needed an open flame. The wheel lock removed the flame. The wheel lock was expensive. The flintlock offered a simpler alternative. The musket couldn't easily defend itself in close combat. The bayonet solved that problem. The flintlock eventually gave way to percussion ignition, and each improvement made firearms more practical, more reliable, and more powerful. But technology doesn't spread by itself. It travels through people, through trade, through war, through conquest, through curiosity. Chinese engineers created the early technology. Mongol armies carried knowledge across Asia. Ottoman soldiers adopted and refined firearms. Japanese craftsmen transformed imported designs. European engineers developed new mechanisms, and eventually these technologies became part of conflicts that reshaped the modern world. The history of firearms is therefore also a history of cultural exchange. An idea born in one civilization can be transformed by another. A weapon created for one purpose can be redesigned for something completely different. A technology can travel thousands of miles and centuries into the future without anyone knowing where its journey will ultimately lead. And perhaps the strangest part of the entire story is how far the original intention was from the final result. The first alchemists weren't trying to build a gun. They weren't trying to destroy castles. They weren't trying to overthrow knights. They weren't trying to reshape global politics. They were searching for immortality. Instead, they discovered an explosive chemical reaction. Other people saw what that reaction could do. Military engineers found ways to contain it. Craftsmen found ways to control it. Soldiers learned how to use it. And generation after generation, humans kept refining the idea. From a burning mixture in an ancient laboratory to a tube strapped to a spear, from a bamboo weapon to a bronze hand cannon, from a crude firearm to a matchlock, from a matchlock to a flintlock, from a flintlock to the modern firearm. The people who created the first gunpowder weapon could never have imagined where their discovery would eventually lead. And that may be the most important lesson in the history of technology. The inventions that change the world are not always created with that purpose in mind. Sometimes they begin as accidents. Sometimes they begin as experiments. Sometimes they begin with a completely different problem. But once an idea exists, it can travel, it can be copied, it can be improved, it can cross borders, and eventually it can change the course of history. The first firearm was not born in a factory. It was not designed by a modern engineer. It began with an experiment by people searching for a way to live forever. They failed at that goal, but in the process, they created something that would survive for centuries, a discovery that would transform armies, redesign cities, bring down old military systems, and ultimately become one of the most influential technologies in human history. They were looking for immortality. What they found was something far more explosive.